Hey everybody, welcome to ARE Live. I'm Mark Tier, the founder of Black Spectacles, and today we're going to be covering project planning and design. We're going to be using a mock exam, and through that we'll cover several topics in this particular division of the ARE. During this episode, we're going to share the answers to this mock exam and discuss the specifics to why the answer is correct. The review that we're going to do here will help you prepare for how to think through ARE questions so you can be confident while taking the exam. In our next ARE Live broadcast, we're going to discuss project development and documentation with Mike Newman. We're going to also use a mock exam to cover some of the knowledge and skills relating to things like building materials, building systems, detailing and documentation, specs, and adhering to code requirements, among other things. If you'd like to register for that, you can go straight to our website and go to blackspectacles.com/podcast and register for that one if you'd like to attend. I'm excited to tell you guys about something new. We actually just launched our first online forum, which we're calling the ARE community. And so if you go to community.blackspectacles.com, you can find it. It's a free community. And it's for those of you who have questions relating to specific material on the test. For those of you who want to network with other architects or even give back and share your knowledge and experience to help others on their journey to licensure. One thing to note is we actually post a 5-question practice quiz every week to keep your skills sharp. Again, that's free, so be sure to check that out as we continue to add more and more exciting things to community. Again, if you want to just go straight to community.blackspectacles.com, you can find it there. Otherwise, if you just go to our website and you look under Engage, you'll find a drop down there that says ARE Community. So really excited about that. A lot of you have been asking for something along those lines, and so we have a whole team of people behind that, which should be really successful. One thing I always mention on this podcast, if you'd like your boss to pay for your Black Spectacles membership, be sure to tell them about our firm licenses, whether you work at a 10-person or 10,000-person firm. We have all sorts of different options that work for all kinds of different sizes of firms. And we're actually doing a webinar on January 15th for our Black Spectacles. It's called our Black Spectacles ARE product demonstration, where you can learn about the differences between individual and group subscriptions. So I just dropped a link so you can register for that in the chat box as well. And for those of you who think there's no chance your boss is going to pay for your Black Spectacles membership, we have a special coupon code that we'll be sharing for individual memberships today. Let's see here. So you guys can stay tuned to the end of the episode for that. Today during the webinar, we're going to be tracking everyone's answers, and everyone who gets them all correct will win a free Black Spectacles t-shirt. So listen up to the end to see if you're one of the winners. And of course, our instructor today, or my guest, is Mike Newman. He's a senior lecturer at the School of the Art Institute of Chicago, as well as the founder of Shed Studio, and he's our instructor for Black Spectacles online ARE exam prep lectures. So thanks for joining us today, Mike. And as always, we'll be taking your questions through the GoToWebinar question box. And with that, Mike, I'll hand it over to you.
All right. So as Mark said, we're going to be talking about project planning and design. And just a quick reminder that there's out of the 6 exams, there's the 2 that are practice and project focused, sort of overall exams. And then there's the analysis exam, which is sort of the first of the 4 sequence that are sort of in a time lapse, if you will, of how a project goes forward. And then this one, the project planning and design. So the analysis one that we talked about at the last of these is really focused on the kind of what happens right at the beginning and just before a project really starts. So the contract negotiations, getting the surveys, understanding some of the things that need to be analyzed, like environmental conditions and code issues and things like that. Now, this one then, project planning and design, is really meant, it's sort of somewhere between schematic design and design development. You're kind of on that part of the spectrum. So now you're thinking about design, you're maybe still doing some analysis, but you're moving into actually making some decisions. And so we're really talking about like, what are the key elements that are going on during that kind of schematic design, design development kind of period of the architect's thinking. And then the next one, which really ends up being about documentation, is kind of the CD set, permit set kind of time period. So it's finalizing all of finalizing the decisions, making sure that the material choices meet the codes and all of that. And then the final one would be the one that's during the construction phase. So like I said, we're going to focus on project planning and design. And I always like to sort of put it into that context because it's important that you get used to answering questions in the appropriate context. Because really, many questions could be asked at any of those. You know, something like something about sustainability, or something about a code aspect, or something about structures. The same question essentially can be asked in many of the different exams. It's just that you would answer it differently given where you are in that timeline. So it's just important to keep that context in your head as we're kind of going through these things. So let's jump in. Okay, so number one, during the transition from the design development phase to the contract documents phase of a 3-story brick veneer with CMU backup wall multifamily housing project, you have been tasked with determining whether the design is still in line with the original program budget. What is the likely system of uh, determining whether this is actually still the case? So in other words, what's the system of figuring out the budget that you currently have on your design right now, and does it match the original budget that came from the program? So we have a couple of possibilities here: assemblies, individual line items, comparables, and cost per square footage. Let's think about a couple of these. One, comparables is kind of an interesting one, right? Comparables is really where at the very beginning of a project, you might say, all right, well, how much do we think this high school is gonna cost? We did a high school 2 years ago, and it was for 500 students, and it was, you know, I don't know, whatever, $15 million, probably more than that, but $15 million for 500 students. And this one's going to be for 250 students, but it's 2 years later, so it's a little half, maybe a little bit more than half. So that was 15, so 7. So let's say it's about 8 million. That would be an idea of using comparables. Now you can be more specific than I just did it, and you can be a little more fine-tuned than that. But essentially, you're basing a concept of cost off of previously done work, either by your own firm or by other people nearby. It has to be local to that area because costs vary so much across the country. So comparables is a great way to figure pricing out during programming, and maybe early kind of understanding what the basis of the contract should be. But at this stage, comparables really doesn't fit. It's not something that you would be dealing with at the design development level. And then cost per square footage is another one kind of similar. So you might start with comparables, and then as you're getting into schematic design, you would probably start thinking about the cost per square footage. And you can be pretty darn accurate with a sort of general number where you say, yeah, you know, multifamily housing, we've been able to do it for $210 a square foot, something like that. And you know, maybe it's a little fancier, so okay, we're going to go up to $240, $250 a square foot. Maybe it's a little more bare bones. All right, maybe it's 180 a square foot, something like that. So you can kind of use that as a sort of barometer and get pretty close. But again, that's really something that would be focused on schematic design. You're talking on this question about being well into design development, getting ready to transition over to contract documents. So that leaves us with assemblies and individual line items. And the answer is going to be A, assemblies. And the reason for that is that individual line item is a full out bid And that's where you're literally individual, every line item you can think of is getting individual focus. And that's something that really an estimator or a contractor would do, not typically what an architect would do. And assemblies, though, that's where you've got enough information, which this is, we're talking design development at this point. You've got enough information that you can say, yes, the exterior walls are brick veneer with a CMU backup. There's going to be drywall on the inside. There's going to be a certain amount of rigid insulation in the air gap between the brick and the CMU. There'll be flashing. There'll be ties. There'll be some building wrap. All of those things. We can kind of put all of that together into what's referred to as an assembly. So that's the exterior wall assembly. And then say, all right, we can look it up and we can find out that per linear foot, that costs X amount. And then we can add up all the linear feet and we know how much the exterior wall roughly is going to cost. It's not going to be exactly perfect, but it'll be pretty close and it'll be definitely more accurate than going with like a cost per square foot. Assemblies are kind of interesting because there's linear foot, so like exterior walls, interior partitions, things like that. Then there's going to be square foot assemblies, so that would be roof assemblies, floor assemblies. So floor assembly might be like TGI pre-engineered wood joists at 24 inches with a plywood structural deck, maybe some sound deadening layer there for impact sound, some sound attenuation in the spaces between the joists, and then how about a resilient channel underneath, and then a drywall. So that whole thing, I can get a number for what that whole assembly is per square foot. And so that allows me to sort of then add up all the square feet of that particular assembly, get a price for that, and obviously you just keep going until you've kind of filled all those things out. So some assemblies are going to be per linear foot, some are going to be per square foot, and then some things will be per individual item. Like let's say for this multifamily housing project, maybe there's balconies and every unit has a patio door. So there's no logic to per linear foot of patio door. That doesn't make any sense. So it would be, maybe it's 20 units. All right, well then there's 20 of those patio doors. So some are going to be linear foot, some are going to be square foot, and some will be individual unit. But it's a fast-ish way of putting together a pretty real full-on estimate. It's not as real and as specific as full individual line items, but it's definitely better than comparables and definitely better than the cost per square foot and fits to that moment in the timeline of the project.
Okay. Yeah, 160 people there, Mike, remaining. So you
All right.
you got you got quite a few there.
We'll see if we can trip up some on the next one. I always say this, remember, this is just me writing these out in order to have some things I want to talk to you about. So they're not necessarily like if I fooled you on something, don't fret about it. It's not meant to be like, it's great if you get it, but don't, use it as an opportunity for thinking
Don't
about
don't don't be mad at Mike. That's what you're trying to
it.
say. Please don't be
That's what
mad
I'm
at me.
trying to say.
Okay.
You can be mad at Mark if you want, but don't be mad
Yeah.
at me.
Fair enough.
All right, number two. After years of flooding and all the calls from irate taxpayers and voters, your local town has instituted a very robust set of regulations about stormwater issues. Which of the following are probably part of the regulatory structure? Choose three. So this is something that's actually happening essentially all across the country. That there's just so much built up hard surface, roof, parking lots, roads, that we are collecting this huge amount of water and nobody really knows quite what to do with it. And as we get these storm surges, you then get these backups that supercharge our stormwater systems, which in most of the country, not all of the country, some of the country has separate systems, but most of the country, the stormwater is combined with the sewage system, which is for obvious reasons, because it's just cheaper to do one system than it is to do two completely separate systems. But obviously the problem with doing one system is that if you get a lot of extra stormwater, it's going to supercharge that sewage system, and then you're going to start getting backups at the lowest points around, and that's going to be your basement toilets. It's going to be floor drains in basements and in garages and things like that. And so people are complaining everywhere about these backups because they're really unpleasant and it causes a lot of damage. And because we have so many more storms now, that it's just going to get worse and worse because of all the climate crisis issues. So you'll actually find this to be quite a real thing. And there are a number of ways that you can deal with trying to have a robust set of ways of handling stormwater. And a couple of them, I'm just going to give the answers to sort of start us off, because I think it's going to be easier that way. Usually I go the other way, but detention ponds, absolutely. That's something we would totally be part of the conversation. Retention ponds, also absolutely, and I'll talk about the difference in just a second. And then bioswales. So wetlands is sort of a potential answer, but it's not a good answer because that's not something that you are doing to deal with stormwater. It's something that is affected by that process, but you're not making wetlands, except when you're in that specific situation. Like, let's say you're putting in a shopping mall and you really want to put it where there's a wetland. Well, then you can do that as long as you build other wetlands somewhere else. But that's not really a stormwater thing. It's not really part of that as a regulatory structure. It's its own set of issues. It's not about stormwater. It's about the watershed. So wetlands is a potential answer, but not a good one. Hydropartitions is actually a thing I made up, although there are ways I could imagine thinking that that might be a real one, and we'll talk about what those are in just a second. And then filtering systems. Filtering systems are absolutely part of kind of thinking about stormwater systems, but they're not really the sort of robust regulatory structure. They're just, if we want to be able to reuse water, we'd probably filter it. It's sort of a secondary consideration. And detention ponds, retention ponds, and bioswales are definitely on the first line and make more sense as an answer. So detention ponds and retention ponds. Think of all those times you've been at like a office park in the suburbs, or maybe a shopping mall or something like that, and you see a pond off to the side of the parking lot. You're kind of wondering, wow, I wonder why they spent so much money to put a pond in there. Well, that's not just like a landscaping, hey, let's make a nice pond. That's a way to sort of deal with the sort of rise and fall of all of that excess water. When you have those big parking lots and those big roofs, that water has to go somewhere. And so you're going to retain that water in a retention pond, retention, and it's going to be a place for that water to go, and then it will eventually evaporate away, and some of it will go down into the soil, but you'll pretty much always have a pond there. A detention pond is where you're detaining the water for just a short period. So it's essentially a low space on your site that allows that excess water a place to go that it can then fill up and then slowly be drained away, either into a stormwater system that has a restrictor on it in order to make that not supercharge the overall sewage system. You're just letting the water in slowly. Or maybe you just have certain types of soils there, and it allows it to go into the ground to the water table eventually, as well as evaporating away and getting used by the plants. So the detention ponds have to be landscaped in such a way that the plants there can get very, very wet and then dry out, because it goes wet and then dry and wet and then dry, whereas a retention pond stays pretty much wet all the time. Bioswales is like a detention pond, but it's sort of more of an everyday, it's sort of a place where you specifically are choosing plants and soils that can get very wet and then drain out through the soils. Detention ponds often have connections to storm sewers. Bioswales can, but rarely have connections to storm sewers. Usually you're just using the soil themselves. That may be different in different parts of the country. Some places may be more focused on storm sewers than others. I'm not 100% sure about that. But the idea of the bioswale is that it's a smaller scale. You have more of them. They're spread out, whereas a detention pond tends to be pretty big. So detention ponds and retention ponds are the kinds of things you would find on bigger projects, not really urban projects, because you need space in order for those to work. Bioswales are a little smaller, a little tighter. That can be a more urban as well as suburban approach. And then obviously other systems that could be listed here that would have been correct answers if they were, we could have porous pavers instead of hard surface parking. We could have green roofs that absorb massive amounts of the water that gets collected on that roof and eventually lets it evaporate away into the night. We could have porous concrete instead of hard concrete. We could have cisterns where we're collecting water from either roofs or parking or any other hard surface, and use that for watering lawns and things like that. So cisterns would be correct, porous pavers would be correct, green roofs would be a correct answer here, et cetera, et cetera. There's lots of different potential answers. In the particular run of 6 here, detention ponds, retention ponds, and bioswales are the best answer.
All right, I think we're down to about 100 folks actually, so that a lot of people got that one right.
Cool. All right, number 3. 3-story office building you are designing has 9-foot ceiling heights throughout. In trying to formalize the building sections and the egress stair layout, you review with the structural engineer and the M&P engineer and receive the following information. Structural wide flange beams and girders are 21 inches max. The corrugated steel deck with the concrete fill is going to be about 5 inches max. The largest duct is likely to be a 40 by 24. And the clear area above the drop ceiling for the light fixtures and the sprinkler layout is expected to be about 10 inches. And the question then becomes, all right, how many risers are there between the second and the third floor? So this is a pretty simple question. It just has a lot of information in it, but it's actually a very simple idea. All you're really trying to figure out is what is the floor to floor. And so we know what the floor to ceiling is, but if we're trying to understand what the stair pattern is, how many risers, how many treads, how big the stair is going to need to be, we need to not know just the floor to ceiling, we need to know the floor to floor. And so by just adding it up, we can get a pretty good idea. So if you can kind of imagine, you've got, floor system, I've got wall here, there I am standing in the space. I've got decking there. I've got the wide flanges, the structural system underneath that. I've got space for the ductwork. And then I've got this other space, which if you're not used to it, may sound a little weird, but it's that last little 10 inches that they've left for the light fixtures and the sprinkler layout. Now, the reason that we do that is because this is an office building. It's an office space. Now, you don't have to do that. You don't even have to have a drop ceiling. There's lots of different ways that this can get done. But office space is typically understood to be quite different from residential space. You might change things in residential, like if somebody moves out of a condo and somebody else moves in, they might change the colors, they might take a wall out, they might do this or that, but effectively it's going to be the same basic layout. At least that's the expectation. Whereas an office space in an office building, people are going to change that pretty regularly. Every 5 years, it's probably likely to have a new layout. as one business moves out, another one moves in, or the business that's holding it has some change in the way that they're organizing things, and instead of lots of small offices, now they're doing one big open office with then office corrals in it or something like that. And they need to be able to change things like the lighting patterns, where the HVAC is coming out, how the sprinkler heads are working. And so there's an expectation of flexibility. And so what that means is that's leaving us this space here, that last 10 inches. And sometimes you'll see people will talk about it as 12 inches, 11 inches, maybe down to like 8 inches. I think with the kind of rise of LED lights, there's a bunch of new low profile LEDs. I think you're going to start seeing that number come down a little bit. But what that's doing is it's giving that space where we make sure that none of the ductwork and none of the structure is in that space. And then no matter what happens, we can relay out this office space and move those lights around, move the sprinkler heads around, and we know we'll always have that free space open. So it's for the flexibility of the office space. And then the other ones are all pretty just adding up straightforward numbers. The one little catch one would be the 40 by 24 because you have obviously two numbers there. I think there's no reason to assume, unless it said there was a reason to, but since there isn't anything that said there's a reason to assume you would have to go the tall way, there's really no reason ever to do that. So you would always go with the shorter number in this case. So that's going to end up being 9 feet, which is what, 108. And then we've got 21, we've got 5, we've got 24, and then 10. And I believe that adds up to, what is it, 168? Somebody want to check me on that? Let's see here. All right, and then we're going to divide 168 by 7. So, okay, why are we dividing 168 by 7? Well, that's because our assumption is that a public space, this is not like inside your house, this is not in your apartment, this is a public space. That means the stair has to have a maximum riser height of 7 inches. So that's where we would always start. So we're going to divide that and we're going to get 24. So 24 is the correct answer of how many stair risers there will be. How many treads there are would depend on how you lay it out. It gets a little confusing. Talk about that some other time.
Okay.
All right, number 4, to finalize the schematic design for a single-story small gymnasium for the junior high school your firm is designing, you make a reasonably accurate best guess for the structural system for the 68-foot clear span. Choose one. We have Virendale truss, wide flanges, concrete slab, open web steel joists. So Virendale truss is it's just so likely to show up on the exam. It's a kind of old school architectural thing, and it's a weird one because it's a very specific truss that actually isn't a truss. If you think of what a typical truss looks like, where it's got all the diagonals, it's probably not a great version one, but let's add one more there. That's a kind of classic truss. A Virendale truss looks like this. Which is to say it's not a truss at all. Without the diagonals, it doesn't actually function as a truss. But architects, especially those architects from the 60s and 70s, love the Virendale truss. And it has this very cool, memorable name. And so it shows up all the time on the exam. And often you'll see these used as bridges, where the scale is so big that you can kind of walk through it. And architecturally, architects always love them because they don't, without the diagonals, the steel doesn't get in the way of the windows. so it can fit right into a sort of a typical architectural scene. But it's a very well recognized name, but not appropriate. It's very expensive. All of these have to be moment connections in order for this to work. It's a much more expensive system than you would use on something like this, unless there was some really big defining reason why you really needed to, and it doesn't say. So we're definitely not going to be doing Vierendeel truss, but you should know that term because it is likely to show up at some point. Steel wide flanges, so that's just kind of classic steel beams. Steel wide flanges could totally do 68-foot clear span, but they're not, it's not their sweet spot. Like a 40-foot span, a 45-foot span, even up to a 50-foot span is pretty reasonable. 40, 45 is typical. 50, you're starting to get pretty long. 55, 60, 65, you're getting pretty long there. You're going to have a very expensive system. So you could use wide flanges, but it's probably not the most logical for that particular span, given our other choices. So I'm going to say no to that one. Again, that's a correct answer, but it's just not as correct as one of the other ones. So then the last two are six-inch flat concrete slab. It'd be hard to span 68 feet in a 6-inch slab. It could if we had it as a curve, like the ones that Candela and Nervi and people like that used to do. But a kind of classic flat concrete slab, 6 inches, 68 feet, you'd have to have an awful lot of rebar in there. And even with that, I don't think that would really work. So the answer we're going to talk about here is open web steel joists. And this is totally the sweet spot for open web steel joists, especially for the long spanning ones. They make a lot of sense for a single story. That means there's no floor up above. Why would that be important? Because the open web steel joists tend to be a little bouncy. And so you have to kind of over design them if you're going to have people walking on the floors up above. But if it's just the roof up above, and you don't mind a little bit of bounce and give, something that if people were walking on it might feel a little weird, but if nobody's walking on it, then who cares? Then the open web steel joists are sort of like a totally logical, straightforward potential at this clear span, and would be sort of the economic logical choice for something like a small gymnasium. You can pretty easily do that kind of 40-foot to 70, 80 feet range with the open web steel joist. You can go shorter as well. The big advantage of the open web steel joists, right? These are the ones that look kind of like that. The other big advantage, other than being relatively light and kind of comparatively inexpensive for the amount of steel you've got, is that they're open, right? So I can put duct work through them. I can, they don't weigh a lot, so they're not adding to a lot of heavy load to the building for foundation purposes and everything else. So there's a bunch of advantages to them. The big disadvantages, like I said, is that they do have a little bit of bounce. So in order to get the stiffness, they have to be pretty deep, but you're not using a lot of steel. And so that kind of back and forth, for this kind of length, they're really a logical choice for something, a project like this.
All right, I think we're down to 42 people, Mike.
All right. All right, number 5, the standpipe is located where? Probably. We have fire-rated egress stair aligned with the main vent stack, part of the plumbing waste system with the scaffolding during concrete formwork stage. So this is one that you just have to kind of recognize the term standpipe. A standpipe is so I'm just going to give you the answer here. The answer is at the fire-rated stair. So what's happening here is the easiest way to think of it is picture yourself as a firefighter, and you run into the building, you look at the annunciator panel, it says that the fire is on the 5th floor. you take your hose, you connect it to the fire hydrant out on the street and the sidewalk. Your hose is now filled with water, and you're running up the stairs with the hose filled with water. And people are trying to get out of the building, and you're getting water all over the place, and people are slipping. And it's just, it's just a recipe for disaster. So a way around that is by using a standpipe, which is essentially a pipe that shows up out on the sidewalk and then goes straight from the sidewalk into the building, and then typically right up vertically at the fire rated egress stair, so that that firefighter, instead of taking that full hose up the stairs, goes in, figures out that the fire's on the 5th floor, runs up the stairs or takes the elevator up with their hose. Somebody connects the standpipe out at the street to the fire hydrant. The standpipe itself fills with water as it goes, charges up with water all the way up the building. And by the time the firefighter is up on that 5th floor, they can then connect to that standpipe and with their hose and start putting out the fire. So effectively, the standpipe is part of the firefighter's apparatus that's built into the building. So why the fire rated egress stair? Like, why put it there? Well, there's two big reasons. One, if you were the firefighter, you'd want it somewhere where you could find it easily, right? And if you're going to go up the stairs, you're going to see the thing right there. So you're going to get it very fast. That's great. So that's a useful thing. You don't want them searching around trying to figure it out. The other reason is the stairs are generally considered to be, they're going to be a straight shot. Now, if you get really big buildings, it gets a little more complicated. But if you have a 5-story, 8-story, 10-story building, a 3-story building, you're going to have that stair go from the top all the way down to the bottom. It's going to be a nice straight line. And if somebody in 2 or 3 years decides to redo something, they're not going to move the columns. They're not going to move the stairs. They might move any other partition, but they're not going to move those things. And so you know that it's a relatively safe place to put a vertical pipe like this. The other thing that it gets used for, you can have a standpipe. Sometimes it'll be side by side. Would be as a supplement to your sprinkler system. So sometimes you walk around in the streets in a city, you'll see these little connections pop out on the sidewalk out of the buildings. Often they're two-headed in order to get more pressure if you need more pressure to push it up the building. These little two-headed fire hose connections will pop out, and sometimes they'll say for sprinkler, and other times they'll say for firefighters. Or some other term like that, and they'll both say standpipe. So it's a term that's meant as part of the firefighting apparatus that's built in to your building.
Okay, I think we're down to 39.
All right.
So I got a lot of people holding on here. I think we're going to be
Okay.
sending out a lot of T-shirts.
Yeah, that's all right. Number 6, during the initial project analysis, it was decided that the Denver University building should focus on long-term sustainability. Which of the following seems likely? We have DX rooftop units, R13 wall assemblies, geothermal ground source heat pumps, LED uplighting on the front facade of the building. So let's start with the LED. Obviously, if I'm choosing a lighting system, the LEDs are going to be a reasonable choice. So that's potentially a positive. Uplighting on buildings, when you're talking about sustainability issues, is not really sort of a current way of thinking about it. The problem with uplighting is that you're putting quite a lot of light up into the sky. It's called night sky lighting. And that you're sort of tend to be wasting a lot of the lights, the amount of light, the energy that you're putting into the making of the lights. The other thing it does, lighting up the buildings like that, is it confuses the birds. And so there's all sorts of problems with uplighting on buildings. So let's go to, how about R13 wall assemblies? R13 is just not a lot of insulating power. A place like Denver, you're going to want to have some serious insulation in those walls. And R13 would be a pretty typical old school amount of, back when I was first starting out, we did R13 walls all the time. These days, in a place like Chicago or Denver or any of these places that get pretty cold and also get pretty hot, it would be very unusual if you were doing anything less than R19. I just did a building at R23, and everybody was kind of sort of sad that it didn't go higher. There's been a big sea change over the last, say, 10, 15 years. R13 used to be, not that long ago, a relatively respectable amount of insulation in the wall, but these days it's just not, especially in a place like Denver. So I'm going to say no to D and no to B. So then that brings us to DX rooftop units and geothermal. The DX rooftop unit, that's the concept where if you're talking about air conditioning, the sort of classic system of air conditioning is the 4-loop system. And so that's where I have a refrigerant loop. It's got a compressor and an expansion valve, and that makes a hot side and a cold side. And then on the cold side, I make a bunch of cold water by having the cold refrigerant kind of running in a coil through it. So I have this cold water, and I can then make a loop of cold water, bring pipes around to wherever the air handling units are going to be. So that's fine. And then I have an air handling unit somewhere. Maybe I have 10 of them, maybe I have one of them, doesn't really matter. The loop just goes to all of them. And I let that cold water go and become a coil in front of a fan. So I have the refrigerant loop, so that's this one. I have the chilled water loop. And then I have the air loop. Different people will call these slightly different things, but you get the idea, I hope. And the air loop is I have that fan, it's going to blow across that coil, and I'm going to get air blowing out into the space. And then eventually it'll become return air that's brought back, and it'll get reconditioned by being blown across that coil again. So that's that air loop. So that's 3 of the 4. And then the 4th one is on the hot side, I've got another barrel of water, and I take that water and I go up, presumably to the roof, but doesn't have to be, could be somewhere else. And I do a cooling tower on the roof, and I let the air take away a lot of that excess heat. So the refrigerant has put heat on one side by pulling it out of the cold water on the other side. So I'm pulling heat out of the cold water and making it colder, and I'm putting it into the hot water on the other side. I'm then getting rid of that excess heat. And that cold water, once I've made that cold water, now I'm sending it around the building, and I have the air side loops to be able to kind of blow around. So this is the heat rejection loop, and that's all 4. So that's a classic system. A DX rooftop unit is more like what your window box air conditioner is like. So that's, if you ever taken one of those air conditioners and you buy one at Home Depot or something and you go put it into your window, that has all of this. It has a refrigerant loop, it has the air loop, it has a heat rejection system, but it doesn't have any of the water. So there's no water involved on that one. And the DX refers to using the refrigerant as the coil for the air side loop. So it's a direct relationship between the refrigerant and the air loop. It's a great system for simple settings, for straightforward, off-the-shelf pieces. It totally makes sense for certain kinds of units, but it is absolutely not going to be the most sustainable version of what's going on. By far, the best choice out of these 4 is going to be the geothermal, and that's where I'm using the fact that 6 feet, 8 feet below grade, I can count on the fact that it's going to be about 50, 55 degrees, and I can either in the summer take excess heat from the space and put it down into the soil, or in the winter by using a heat pump, I can take heat from that soil because I know it's going to be 50, 55 degrees. I can pull heat from there, put it through the heat pump, and use it in my space. So it's a great system. The downside is the geothermal ground source heat pumps are very expensive first cost, but over a long span, which presumably a university building would be looking out on the 25 to 50-year time horizon, over the long span, they're totally going to make sense, especially if you're interested in sustainability. Geothermal totally makes sense as the answer for this question.
All right. Thank you, Mike. I think we're down to 34 people here, so I'll come back to that in a second. We did have one good question here. Mihul asked a question going back to one of the earlier ones.
Mhm.
Considering bioswales are not connected directly to the storm system, why would the local town regulate it? Is the question there.
Um, it's part of a system that you would have, as well as like tanks of water under your parking lots and cisterns and all those other things that I mentioned. You have to show that at the highest point, um, different municipalities will use different ways of talking about it, but like you know, 100-year storm or 200-year storm, things like that, to say, okay, this amount of water is expected at a 100-year storm. You're not expected to be able to handle a 500-year storm, but at a 100-year storm, you should be able to say where all that water is going to go. And so a bioswale would be one example of where you could say, well, you know, 4,000 gallons will go to the bioswale. 110,000 gallons will be taken in the cisterns and in the storage underneath the parking lot. Like you would have to add it all up and show that you can meet that requirement as the rain comes through on an expected level. It's not going to be the worst possible rain that you would have to be able to show you can maintain, but it would be a very bad rain that you would have to show that you're not letting excess water off of your site and flooding other people or the storm system.
Okay.
So it's
Um,
one of many that you would show.
yeah, that makes sense. One more question here from Tyler. His question is, does geothermal make any sense, in a part of the country that has a lot of bedrock?
Oh, that's an interesting question. Well, you can actually do geothermal vertically or horizontally.
Yeah, that's right.
Um, and so the vertical ones, which is the more typical, tend to be really deep. You know, you're going down like between 200 and 400 feet. I think 300 is pretty typical. And so you have these really deep, and the people who build them are essentially people who do like wells and things like that, like where they have all the infrastructure to do those big deep holes. But the reason that you do them vertically is not because they're better, it's just because we tend to only own a certain piece of land. And so, you know, we don't have a lot of extra space usually. And so it's just easier to go straight down than it is to go sideways. But you can, as long as you're deep enough that you're at the point where that's that steady state temperature, you can go horizontally, and I've seen a number of them done that way. It's just you take up a lot of space, and sometimes they'll then put a parking lot on top of it or something like that. Like there's various things you can do to then use that space, but it's a little harder. So yes, if its bedrock is close, then absolutely you could probably do it horizontally. If the bedrock is even closer, then no, you're not going to be digging through bedrock for
Okay,
geothermal.
beautiful. So everyone else, we're out of time here. I have a couple things to announce, but I would recommend, now that we have this community, online community, if you guys want to go to community.blackspectacles.com and share your questions there that haven't been able to be answered so far. We will be manning the community and answering all the questions that you guys have. So at our next ARE Live podcast, we're going to again use a mock exam to review issues related to project development and documentation. Um, uh, we're posting the link right now to register for that coming up. So, or otherwise, you can go to blackspectacles.com/podcast to sign up. Um, as we mentioned, of course, you can learn more about our exam prep curriculum over to blackspectacles.com. You can try out some of the course videos for free. And then, of course, if you want your boss to pay for your membership, be sure to visit blackspectacles.com/firms to learn more about our firm memberships for firms of any size. For those of you who are ready to start preparing for the ARE right now, you can use coupon code PPD121919
BKS.
to get a 15% discount for the entire duration of your exam prep membership. And in terms of winners, holy smokes, we have 34 of them here who are going to get a free Black Spectacles t-shirt. I'm going to
Well
read their
done.
names as fast as I possibly can. We have Dustin A. from Woodley Architecture Group, Greg F. from PA, Shane David from HDR, Jeff from March Associates Charisma. We have Kevin from WATG, Jesse D. from Colsat and Associates, Jory C. from Leaderbach and Graham, Drew M. from BEA, Ruben C. from SOM, George from Gray Architects and Engineers, Joseph A. from Borges Architectural Group, Rancelina S. from Rogers McCagg Architects, Chen Z from Perkins Eastman, Melidia H, Amanda G from HED, Zihan W from Perkins Eastman, Nicole L from SSW, Michelle C, Young K from Tan Architect, Paige C from Labella PC, Entria K, Carla C, Department of Military Affairs, Michael B from Off Gang Architects, Marcello F from MF Design, Paul G, Erwin I from TI Architecture, Natasha from Department of Buildings, Chris A from Johnson County Government, Jacqueline M from SCB, Michael V from Ware Malcolm, Nathan T from RG Architects, Molly V, and Priya N. If I misspelled your name or your firm's name, my apologies. But congratulations to all of you. We will be in touch via email to provide the details for receiving your free Black Spectacles t-shirt. Finally, tomorrow we'll email you a follow-up about today's live broadcast, so please let us know what you think. Share any suggestions that you may have. We read every word that you guys write and use them to tune our next episodes. So thanks for watching.